Hello, I am going to finish 5.3 on exponential functions, and we're going to look at solving the exponential equations. So for this section, we're going to be trying our best to keep them in exponential form. We're going to see in the next section that if you can't do what we're about to do, you can change the form into a log form and go from there. But for now, we're going to stick with this type. So how would I solve something like this? Well, hopefully you can see the common sense would tell you that if 3 to something needs to equal 3 to the 5th power, what does that power have to be? 5. So basically, if you can ever get an equation to look like this, where the bases are the same, the only way that these two things can be equal is if the exponents are equal. So in this case, we would be done. But in some other cases, there might be some more work to do. So looking at number 2, this is a case where, again, it's already set up. 4 equaling this stuff needs to equal 4 equaling 2, or to the 2nd power. So I need to set up an equation where those exponents would equal each other. So would it have mattered if the bases were 10 or 15? No. If the bases are the same, you can basically ignore them and set the two exponents equal. So in this case, to solve, I would subtract 1 and then divide by 3. So x would equal 1/3. And you could plug that in if you were iffy on it and make sure that they equal each other, but they do. So the issue comes when we get to number 3 and we do not have the same bases. So like I said, there's some more complicated things we can do to change this. But in this case, maybe we could just rewrite one of the numbers to make it the other one. So I'm not going to try to make 4 16 to the something, but I can think about maybe rewriting 16 as 4 to the something, and we can, right? So I'm going to keep this one the same, but I'm going to rewrite 16 as 4 to the 2nd power, because that is 16. But just keep in mind that it's also being raised to the 8x. And now I can set the exponents equal, as long as I remember the rule for raising a power to a power, which is when you multiply. So on the right side, I had to multiply that 2 times the 8x. But now I solve this, but keep in mind how I solve something like this would be to get everything on the same side and see if I can factor, which I can. So then you would set each of these equations equal to 0 and solve, and you would get positive 18 and negative 2. So these are both our answers. 4 is ready to go. I just wanted to show you that E is the same as it being a 4, because E is just a number. E is 2.714, blah, 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 blah. So again, I can just ignore the E's and set the exponents equal, and then decide how to solve. Divide by negative 2 at the end, and you'll get negative 7. Again, if you're ever iffy, plug them in and you'll see that they match. Okay, 5 is the same idea, but again, we have to remember a couple rules with exponents to simplify this, because right now I don't have just an e to something and an e to the something, so I need to combine this. So first, remember with exponents that if you would like to bring something to the top, you can do that as long as you change the exponent. So instead of a positive 3, I could bring this up top and make it a negative 3. And now they're next to each other being multiplied, so I can put them together as just 1. As long as I remember, you can do that by adding. So 4x plus a negative 3 is basically just 4x minus 3. So now I can set the exponents equal to each other and solve by getting everything on one side and seeing if I can factor, which I can. So x minus 3 and x minus 1 are my factors. So if I set them both equal to 0 and solve, I would get positive 3 and positive 1. Okay, number 6 is very similar to number 3. So if you want to pause and try it yourself, you could rewrite this So 2 is fine, but 4 I could rewrite as 2 to the second power. And now I'm ready to go. Set the exponents equal and think about what you need to do to solve. Okay, number 6, fractions. Just keep in mind that fractions work the same way as a normal number. It's just if you want to rewrite it, you need to make sure that the top and the bottom of the fraction are going to work. So if I'm looking at a 2/5 over here and an 8 over 125 over here, this is the one I'm going to see if I can rewrite. So just starting with the 8, how could I rewrite an 8 to have the same base? Well, I can make it 2 to the third power, right? So this will only work if the bottom can also be written as something to the third power, which it can. 5 to the third power would be 125. So that means I can rewrite the 8 over 125 as 2 over 5 to the third power. So again, 2 to the third is 8, 5 to the third is 125. So that's why I'm allowed to do that. Well, now this is easy. They match. I set the exponents equal to each other, and we're done. All right, 7's a little trickier because you could try to rewrite 128 as 64 to the something, but it won't work. You could go a little smaller and maybe make them 8 to the something, won't work. 4 to the something, won't work. So I basically was playing around with the numbers and finally went all the way down to 2. 2 would work because 2 to the 7th power is 64. I mean, sorry, 2 to the 6th power is 64, and 2 to the 7th power is 128. So then I just need to have whatever else was there, and remember that the rule is to multiply, so be careful. If you're multiplying something like 6 times all of this, make sure you actually distribute that 6 to everything. So I believe that's 216. So do you see I distributed the 6 to the negative x and to the 26, and then 7 times x is 7x, and now I'm ready to solve by adding 6x and then dividing by 13. Let me cheat and use my calculator to make sure. Oh, it was this. I don't know what I was doing here. 6 times 26 is 156. I knew something was off. And now if I divide that by 13, it works out nicely. Okay. Sorry, I was trying to go too fast. Okay, so again, this 156 came from 6 to the negative x plus 26, so I had to distribute it. And then at the end, divided by 13 to get 12. Okay, number 8's a little easier. Most of you, I think, would see that you can rewrite the 36 as 6 to the second. So it becomes x squared minus 120 equals 2x. Get everything on one side. It also helps that I have more room here. So give yourself lots of room when you're trying these so you don't try to rush. All right, two numbers that multiply to 120 or negative 120 and would get me to negative 2 would be negative 12 and positive 10. Set each of these equal to 0 and solve. And we get positive 12 and negative 10. Okay, and the last one is another fraction, so if you want to pause and try it, but you can probably rewrite the 64 over 27. And you can. 4 to the third is 64. 3 to the third is 27. So 4/3 to the third would do it. And that leaves you with x equaling 3. So remember, the trick is if the bases don't match, try your best to see if you can rewrite them to make them match. If you can't, because there will be some where there's just no way to rewrite it, then there will be another way to do it. But for now, leaving them in exponential form, this is what you want to do. Let me know if you have any questions when you try the homework.